In the silent void of space, where sound might seem non-existent, the universe is a symphony of unheard voices. Each celestial body, from our moon to distant planets, vibrates with its own unique energy. As we delve deeper into space, we're encountering these cosmic whispers, some beautiful and some, well, a little unsettling. Today we'll explore some of the strangest recordings NASA has ever captured, offering a glimpse into the mysterious soundscapes beyond our world. Our ears are finely tuned instruments, but they rely on a conductor, sound waves rippling through a medium. In the vast emptiness of space, with no air to carry vibrations, these waves fall silent. However, space isn't completely mute. Many other types of waves, like radio waves, travel freely through the vacuum. These cosmic messengers allow us to translate the whispers of the universe into a form we can understand. Over the past 2 decades, our robotic explorers have ventured further than ever before. Some have even crossed the threshold of our solar system, becoming the first ears to listen for interstellar voices. But are these sounds meant for us to hear, or are they echoes of a cosmic conversation we can only begin to decipher? Let's take a closer look at Mars, our fiery red neighbor in the next lane. Long considered a potential future home for humanity, Mars wasn't quite as fortunate as Earth when it came to finding the perfect spot in the sun's habitable zone. As a result, it lost out on a lush environment and now exists in a more desolate state. Despite its current tranquility, Mars isn't entirely silent. Tremors rumble beneath its surface, hinting at a dynamic past. In 2018, NASA's InSight lander touched down, equipped with a seismometer, essentially a stethoscope for the planet, to take its first comprehensive checkup since its formation billions of years ago. And in April of 2019, InSight recorded its first Martian heartbeat, a tremor deep within the red planet. This video features a recording captured by InSight on April 6, 2019. The sounds you hear are a combination of 3 distinct events: vibrations caused by Martian wind, a tremor on the Martian surface, Marsquake, and the robotic arm of the spacecraft itself moving to take a picture. The resulting soundscape bears an uncanny resemblance to the chilling monoliths featured in Stanley Kubrick's classic film 2001: A Space Odyssey. It's a reminder that the sounds of space can be as strange and unsettling as they are captivating. The sound of interstellar space. Brace yourself for a unique auditory experience. This recording isn't your typical extraterrestrial sound. It's a scientific interpretation of data collected by Voyager's plasma wave instrument between 2012 and 2013. This time frame coincides with Voyager's theorized exit from the heliopause, the boundary of our solar system. Essentially, you're about to hear the first sounds ever captured from interstellar space, translated from raw data. While some might expect cosmic symphonies, be prepared for something unexpected. The sounds you're about to hear are unlike anything on Earth, and some might find them unsettling. Could this be a glimpse into the true nature of interstellar space, or simply a unique byproduct of our measurement methods? Let's listen and find out. The Sea Lord's Thunder. Even before humanity ventured beyond our solar system, the name Saturn, inspired by the Roman god of the sea, hinted at its turbulent nature. Pioneer missions like Voyager paved the way, but it was Cassini that truly unveiled the majesty and power of this gas giant. Cassini's remarkable journey provided the first definitive evidence of flighting within Saturn's atmosphere, solidifying the aptness of its mythological namesake. In 2006, the probe captured crackling radio waves, a testament to the chaotic energy churning beneath the planet's swirling clouds. These sounds offered a glimpse into the raw power of a true storm god. decade later, Cassini delivered another awe-inspiring feat, capturing the sounds of traversing Saturn's rings. This recording, made in 2016, allows us to experience a thrilling and potentially perilous journey through this mesmerizing realm. The static you hear is a direct recording from Cassini's instruments as it crossed the ring plane, offering a unique perspective on a celestial spectacle. The voice of a god. Jupiter, the undisputed king of our solar system, plays a vital role. Its immense gravity acts as a shield, deflecting dangerous comets and asteroids from threatening the inner planets, including Earth. This protective role echoes the Roman god Jupiter, for whom the planet is named. Interestingly, Jupiter nearly formed into a brown dwarf, a failed star. This gas giant continues to captivate scientists due to its dynamic and complex nature. Thanks to the Cassini mission's historic journey to Saturn, we gained a unique perspective on Jupiter in 2001. During a gravitational slingshot maneuver around the gas giant, Cassini captured intriguing radio signals, an otherworldly symphony unlike anything heard on Earth. Perhaps this wasn't entirely unexpected, considering Jupiter's association with the Roman thunder god. However, this wouldn't be our last encounter with the sounds of Jupiter. As Voyager explored Jupiter, it captured a fascinating phenomenon, the bow shock. The sun constantly emits a stream of charged particles called solar wind. When this wind encounters a strong planetary magnetic field like Jupiter's, it gets deflected. This deflection zone, where the wind's energy converts to heat, is called the bow shock. The recording of the bow shock is undeniably powerful. The intense sounds might resemble a pressurized cooker releasing system, creating a sense of unease reminiscent of movie horror scenes. In contrast, a more recent recording from Jupiter captured by the Juno spacecraft in 2017 has a more intriguing name, the groovy track. Named after Juno, the Roman goddess and wife of Jupiter, this audio represents plasma waves within Jupiter's ionosphere. The groovy track might evoke comparisons to the sounds of advanced technology, similar to what was depicted in the film 2001: A Space Odyssey. Interestingly, the movie's wormhole entrance was located near Jupiter, adding an uncanny layer to this association. Launched in 1989, the Galileo space probe embarked on a mission to unravel the mysteries of Jupiter, its moons, and even asteroids. Equipped with an array of sophisticated instruments, Galileo was a powerhouse of scientific exploration. Galileo boasted a sensor suite designed to monitor the solar wind's particles and fields throughout its interplanetary journey and later within Jupiter's immense magnetosphere. A dedicated scan platform housed 4 powerful optical instruments, including a high-resolution camera for capturing detailed images. Additional instruments like a near-infrared mapping spectrometer, an ultraviolet spectrometer, an integrated photopolarimeter, and a radiometer provided a comprehensive view of the objects it encountered. During its daring venture, Galileo made history with 2 close flybys of asteroids within the asteroid belt. In 1991, it delivered the first close-up images of the asteroid Gaspra. 2 years later, it repeated the feat with asteroid Ida, making an even more remarkable discovery, a tiny moon orbiting Ida, which was later named Dactyl. Galileo wasn't just about capturing close-up images. In July 1994, it offered a unique front-row seat to the spectacular collision of comet Shoemaker-Levy 9 with Jupiter. Following this event, Galileo embarked on a series of orbital maneuvers over the next 5 years, bringing it into close proximity with Jupiter's 4 largest moons, Io, Europa, Ganymede, and Callisto. These close encounters with the Galilean moons led to a groundbreaking discovery. Scientists observed unusual plasma wave patterns, which later revealed individual magnetospheres around each moon. A magnetosphere is a protective bubble, a charged particle surrounding a celestial body, generated by its own magnetic field. This finding indicated that these moons were engaged in a constant magnetic tug-of-war with their giant host planet Jupiter. The audio you're about to hear is a recording of these interactions within the magnetospheres of Ganymede, Europa, and Callisto. Callisto, with the weakest magnetosphere among the 4 moons, exhibits the most pronounced effects. While the sounds are undoubtedly powerful and intriguing, it's important to note that they are scientific representations, not literal recordings. The sound of the sun. The sun, the heart of our solar system, fuels everything within its reach. Its immense energy drives the motions of planets and powers countless processes throughout the solar system. Just like any machine generating power here on Earth, the sun produces a constant hum. As the sun converts energy within its core, its material undergoes continuous motion. Scientists have captured these internal motions as waves, which can't be directly heard in space due to the vacuum. However, by converting these waves into audible frequencies, we can gain a unique perspective on the sun's inner workings. The resulting sounds, presented at a lower frequency for human ears, might surprise you. They share an eerie similarity to the hum of a generator or other machinery. This low rumble can be unsettling, offering a glimpse into the raw power that governs our solar system. So, which sounds from the cosmos will you find most intriguing? Or perhaps even a little unnerving? Share your thoughts in the comments below. And if you like this video, click the next one shown on the screen. I'm sure you'll like it. Thanks for watching.